Once connected to the box, then you'll be able to go in and set up your system. You will also see the icons here. If yours are grayed out, those would be items or modules that you did not purchase with your system. The configuration menu is a set of global parameters that apply to all tests that you might run, whether it's sign, random, shock, transient capture, any of the test modes. In the units, we can define how we would like to view the units when we're setting up tests, or when we're looking at data, or when we create a report. So you can see there's drop downs for each one of these values. So once you've set those, then we can go to the Shakers tab, and here's where we enter the shaker limits of the system that we will be using. There is a selection of several different shaker manufacturers in the built-in database. I will be using the DongLing ES-10-240 shaker. When that is selected, the software will import these values from the database that indicate my force, acceleration, velocity, and displacement limits for random, sign, shock, and also for replication for time history testing. You will see calculated acceleration values along the bottom. Those come from the basic calculation of F equals ma, force equals mass times acceleration. From the database for the shaker, we have the moving coil mass, or the armature, and all moving parts of the shaker. We can enter in our specific mass for our test specimen, our fixtures, and any other additional mass that we may have, such as a head expander or slip table. Notice when I change this value and click outside that field, the numbers up here will update from my calculated G level. This is important when we go in and define test profiles, because the software will help us protect our equipment from running a vibration profile that may exceed the limits of our shaker. The next tab is the input channels. This is where we set up our sensitivities for our accelerometers. Now, my controller, I have the output drive looped back into channel 1. So I will leave this set up as DC ground. Channel 2, let's say I have an accelerometer connected. And we can see in the drop down the different selections here. ICP or IEPE, which is a voltage mode accelerometer, which is most common. This hardware also has a built-in charge amplifier if you were to choose charge type accelerometers. Then across, we can set our sensitivity. There's also the polarity selection here, positive or negative. This is nice in situations where we may have to mount an accelerometer upside down. This becomes very important with shock testing, as that is directional. The next tab is for the email notification. This is an optional add-on for the vibration control system. It's very handy if you want to be alerted on any status updates for your running test, or you want it to send a report to your email upon the completion of a test profile. The next tab is signal style. This is how things will be viewed on your graph. So you can see there's different options for the style of line, the line width, and of course we can change the color. The next tab is graph style. So we can set the background colors, fonts, grid patterns, different things like that. And then the final tab in the configuration is miscellaneous. So graph view, stop refresh signals when test stopped. This is nice for random test profiles, so it keeps the last data set on the screen and doesn't average back down to whatever your background noise is when your test completes. Graph save. This does some automatic saves of your data as well. So that is the general overview of setting up the configuration for the DTC vibration control system. Please check out the other videos for specific setup for different test modes.